In this video, I will show you how to create a choropleth map with D3 and how to shade it in relation to a data variable. A choropleth map shows a geographical area divided by regions, which is colored or patterned or shaded in relation to some kind of variable. So what we have in front is a US state map, and it is shaded from white to various shades of green depending on the employment to population ratio. So the higher employment to population ratio in a state, the darker shade of green it will get. So if I hover over the states, we can see the employment to population ratio. If I hover over lighter areas, the employment to population ratio is low. But as I hover over the darker regions, the employment to population ratio is high. Now this is made up data, so both population and employment ratios are just randomly assigned, so this is not the real data. So I will show you how to create this in D3. In order to create any geographic data in D3, it is important to have understanding of three concepts: GeoJson, projections, and path generators, and how they work in relation to each other. The first concept is GeoJson. GeoJson is a format for encoding geographical structures. It supports variety of types like point, polygon, multi-polygon, and so on. For example, if you want to encode a country, the type would be a multi-polygon. The main things to note is in GeoJson is that you have features, and within different features you have different shapes like multi-polygon, and each of those shapes have different coordinates. And different systems that are designed to read the GeoJson file can read those files and can output different geographical shapes. So here we have a GeoJson file that encodes the map of US. So you have states like Nebraska, you have the shape, multi-polygon, and then you have the coordinates. This is what the system would read to draw the shape of that state. And then you move on to the next state, and the pattern repeats. So this is how GeoJson would encode the geographical information. To actually show you how a system would read, so there's a nice tool here. It's called mapshaper.org. If you have a GeoJson file, and you can actually just drag and drop it here, you can select different parameters. We'll just import it. As you can see, it's read the file and it's actually drawn the map. And we'll do the same thing using D3. The next important concept to understand is projections. Projections is a way to project a 3D shape on a globe into 2 dimensions. There are many different types of projections available, and this is a concept which has been in around for hundreds of years. It was proven centuries ago by Carl Friedrich Gauss that a surface of a sphere cannot be represented into 2 dimensions without some kind of distortion. So whenever you would try to project anything on a 3 dimension into 2 dimensions, you will either get distortion in the areas or you will get distortion in the distances between places or distortion in angles. So if the area is important to you, then you would use something like geoconic equal area or geoazimuthal equal area. These are the projections available in D3. And there are many others. If the distance is important, you will use geoconic equidistant. And if angles are important, you will use geomercator. In this example, we will use geomercator. Just because geomercator is used in many different web tools, and even Google Maps use geomercator. Mercator projection is good at preserving angles, shapes, and direction. This is one of the reasons Google Maps uses it, because at a street level it is important to see that the streets meet at a certain angle. If they meet at a right angle, it's important to see that. Originally, mercator projection was used to navigate in C, again because of its ability to preserve angles. Where it fails is in preserving the size. One of the famous examples often given is that how a mercator projection shows Africa and Greenland to be of the same size, whereas Africa is 14 times larger than Greenland. For our purposes, a mercator projection is going to just serve fun. Some years ago, when you would zoom out on Google Maps, you would see the world map still being shown in 2 dimensions. And as the issues we discussed, once you would zoom out at the world map level, you would see different areas being shown in all the wrong sizes. That's been changed. So now if you zoom out on Google Maps, it actually converts it into actually a into a globe. So if you zoom out, you can see that it doesn't use mercator projection anymore. And by that I mean it doesn't use mercator projection at this resolution. But if you zoom back into 2 dimension, it still uses mercator projection, especially at the street level. The third and final concept to understand is the geographic path generator. So once we have our GeoJSON data and we have chosen our projection, in our case the mercator projection, we will pass that on to the d3.geopath.projection method, and it will convert the GeoJSON into an SVG path. So that's the D attribute. Whenever we use paths in D3, we always provide some kind of path converter, or for example line generator, into the D attribute. In this case, we will be passing the d3.geopath.projection to the D attribute. So let's start coding this up, and I'll see you at the other end to explain the code. Okay, let's run through the code. So there were 3 main components we discussed that we need to put together. The first was the GeoJSON file. So the first thing I do is I load the GeoJSON file. The second was the projection. That's here. We decided we're going to use the GeoMercator projection. And the third was the geographic path generator, which is this. So we then pass the projection onto the geographic path generator. In D3, whenever we are using the path, we have to set the D attribute. In this case, we're just passing the path variable onto the D attribute. Now this is what actually creates the geographic map. So D3 does all the hard work. All we are doing is loading the GeoJSON file, selecting a certain type of projection, creating a path, and then setting the D attribute. So once we've done that, we already have the path. The second thing we have to figure out is how to color each of those states based on the data. For that, I use this fake data. Basically, each state has a population and an employee. So when I'm creating the states here, I'm not setting the fill. to be a single color like green or red or something. So I just have to, based on that ratio, I have to figure out which color to give it. So for that, I created a separate function which grabs hold of the state name, and we can easily get the state name from the GeoJSON file here, and that's what I'm doing here. So d.properties.name gives me the state name. So once I've got hold of the state name, I pass it on to this function. It compares, it looks up that state in the states array, and then it has got hold of the population as well as the total employees. So then it calculates the ratio, and it passes the ratio on to the color density function, which goes from low percentage to the high percentage, and from the lighter shade of green to the darker shade of green. Now, one of the things to note is that whenever we are using these kind of geographic maps, it's really important not to use raw data. So we could have created the map by just using the total employee numbers or the total populations. It's never a good idea to do that. We always should standardize the data. So for example, in our states map, what we've done is we have divided the employees with the total population. Otherwise, if we just show the total employee numbers as raw data on the map, that actually wouldn't make much sense, because one of the states could have a large population and the other state could have a really small population. So there's no way to actually compare this unless and until we standardize the data in this way. Just to show you what difference it makes if you do not standardize the data. So I've just created the same example with the non-standardized data. So in this case, I'm just showing raw employee numbers. So you just do not get the same visual effect that you intend if you do not standardize the data. So in this case, for example, some of the states which are showing to have high employment numbers, for example, Georgia here, if we look at the other ones, that's the standardized map, and you can see that obviously that particular state is not the one with the highest employee numbers when you take the population into account. So yes, it's not to belabor the point, but yeah, it's always a good idea to standardize your data.